Data science has been becoming a growing profession and is also the heart of many organizations. That's why Data Science Portugal was born. The first community created by data scientists for data scientists. DSPT wants to gather anyone who works in the field and chat about any topic over this great subject. All members from our team are committed to make sure that the data science field evolves in a healthier and stronger way. To ensure that the focus is on sharing knowledge, we guarantee that our stage is not a place that supports any commercial or recruitment content, and our kind speakers are committed to share their experience for free. We want you. Let's do bigger things together. Join us at any event all around Portugal or online.
Welcome. We are here again for the 86th meetup, still in a remote format. For more than a year, we are in this format, but still we are here trying to do the best for the community. Today we'll have a presentation by Sergio Olmos, finding the imaginary winner of Euroleague. Euroleague was cancelled due to the pandemic last season. And Sergio was inventive enough to try to find an algorithm to predict the possible winner of the Euroleague. So the agenda for today is the opening meeting, where you have to hear me for 15 minutes. Then we'll have the presentation by our speaker. After, we'll have the question and answering, the typical one, where you write your questions in the YouTube comments and will show us as a banner, and we discuss with the speaker. And finally, the new part, we have a small networking where the speaker will be in voice chat in the Discord from the DSPT channel, and you can interact and ask him questions directly. It's important to iterate again our mission as the DSPT community. We want to share knowledge and break barriers between hobbyists and professionals inside the community. We want to promote knowledge sharing and promote open events. What we don't promote, what we don't want in our events are selling and shameless promotion. So this is a place for sharing knowledge, not sharing job offers. Also important to have a call for proposals. If you or you know anyone that has done any major work in data science, all areas of data science, not only machine learning, please send us, fill the form that is available with this link, and we'll evaluate your idea and contact you for a future meetup. We were, instead of are, we were in 5 cities in Portugal: Aveiro, Braga, Coimbra, Lisbon, and Porto, but now we are operating again remotely. This is our website, Data Science Portugal, where you can find the summaries for all the meetups that we have, future meetups, future events related with data science made by the community of the DSPT and other communities, and job offers and much more related with data science, not only from our own community, but for all the open communities that work in data science. These are social network communities. You have Slack, that is one of the biggest ones. We now have Discord. If you prefer to talk with us in Discord, that is a possibility now. And we have the typical page from Facebook to LinkedIn to Meetup, right? So if you want to contact any of the members of the community for any type of questions, even if you want technical questions and you want to know anything about machine learning, please do. Probably in Slack is a better idea. And second, Discord. Join us and talk with us. Whatever you need regarding data science, we'll try to help you. So join us if you want to belong to this community. A special thing for Lewagen, the sponsor for this meetup. It's thanks to them that we are able to do this meetup. Again, the questions, please just ask them in the YouTube chat. The team will collect them and will show this at the end as a banner. We are happy to announce that there are some partner events. A webinar on data science and engineering that will be or happened in February 3rd. We have to check this. Without further ado, I want to present Sergio Olmos. He's a statistician at IS Global, a data science consultant in Alba, Berlin, and a former professional basketball player in Spain. He has a talk titled Finding the Imaginary Winner of Euroleague 1920. And I want to thank you for being available to do the presentation for us. And we are really happy to hear from you.
Yes. Hello. Thank you for your presentation. And yeah, I'm very excited to be here. So as we're going to talk about the work I've, it's a side project that I did last year. And it consists of just predicting the winner of the Euroleague from last season. As you know, around this time last year, the pandemic hit and the Euroleague got canceled. So I was already working with the data from the Euroleague, and I thought that this could be an interesting project. First, a bit about me. So I was a basketball player for the last 11 years, and but the last May I started working as a statistician at IS Global. It's a research center in Spain, in Barcelona, and I also am a data science consultant in Alba Berlin, which is a team in the Euroleague. And before going full-time working as a statistician, I developed a few open source projects for analyzing basketball generated data that we will see some of it in the presentation. And so that's what I wanted to first talk about, is the state of basketball analytics in Europe. I guess it's not as advanced as in the United States. And I'm especially interested in the open source community. For the basketball leagues in the United States, I'm an R user, so for the NBA or even college basketball in the States, there are a few open source R packages to get data and analyze the data. But at the time I couldn't find anything like this for Europe. Everything that I've seen, it was either not public or nobody was sharing it. So I went ahead and started a project which is what we are going to talk about today. And this is an overview of what led me to this final predictions that I did for last season's EuroLeague. And so I first needed to get the data from the EuroLeague, and I did that with a package that we will see in a bit. And then I wanted to predict the win probability during the game at each event of a game, let's say. But in order to do that, I needed to rank each team so that I had a previous baseline rating of each team in order to predict the probability. And that's when I met the ELO rating system, and I developed it to rank every team in the Euroleague's history. And based on this system, I then created a point spread predictive model that basically predicted the point difference in every game based on these ELO ratings. And with this, I simulated every game from last season in order to find out the winner of the season. And so first, for those maybe not familiar with basketball or basketball analytics, there are several usual types of data that we can find. So it goes from basic game results, score points by each team, to player tracking data, which is not publicly available, and it's hard to find. We will not talk about this today, but and then you can find the general box score, which is points, rebounds, assists, and then also you have probably seen like these shot maps or shot charts where you can see the location of every jump shot, and also the most informative and publicly available data, it's play-by-play data, which is basically a log of every event that happens during the game. And so you can find this data usually in the websites of every basketball league, but it's not easily obtainable. You have to parse basically do some web scraping, and that's what I did. I created the Euroleague R package, which is basically a way to interact with the Euroleague's API, and so with this package you can easily get all kinds of data, play-by-play, shot location, all within R. And I added some functions to analyze and visualize the data. See here with these 2 lines of code, you can get a simple shot chart. It is still experimental. I'm having trouble to find time to keep developing it, but it's usable, and you can get the data and do some cool stuff with it. And once I had the data, what I wanted to get is a model that kind of predicted the win probability at each event of a game. So we talked about this play-by-play data, which is a log of every event. And so it's basically a logistic model where it tries to predict in every situation what is the probability of a given team winning that game. And so I wanted to do this, and when I first started, I realized that I needed a way to rank. I needed a baseline rating, I guess, in order to predict better the probabilities. And so I searched around, and I found the ELO rating system, which was originally developed for ranking chess players, individual chess players, but has later been used in many other sports, and even some of the most famous sport analytics websites like 538 or ESPN use this kind of rating to develop their predictive models. And it's hard to find documentation on how to develop this system, but I searched around and I implemented it. The basic idea is this. It's quite simple, as you will see, but so every team starts with the same initial rating whenever you start the system, and that team's rating is updated after every game. So a team that gains elo points after every win, or loses points after every loss. And this change in points is zero sum, meaning that the team that wins in a given game wins the same amount of points that the loser loses. We'll go over it in the next slides. We are going to see some formulas. And don't worry if you don't understand this. Presentation is not the best medium to present formulas. Just I will go over them a little bit and try to give you a sense of what they do. But they're not very complicated. But that's why I show them, and we go through some examples to try to clarify this. And if you want to go deeper or try to understand a bit more about this system, I added a link to the blog post that I wrote explaining all this. Okay, so this is basically the rule that we are going to use to update after every game. So it's basically, as you see, it's simple. It's the rating of a given team before a game. It gets updated by adding or subtracting, depending on the result, a given amount, and that amount is determined by two factors, I guess. This factor right here, so we see that S is basically an indicator variable, which takes 1 if for a win and 0 for a loss, and this P is just the expected probability that the model, so the probability that the model expects for that game. We will see how we calculate that. So NK on the other side is basically a tuning parameter that indicates how much the model should react to a given game, to a given result. Let's see an example. So let's say that Real Madrid and Barcelona played yesterday, and Real Madrid won. And these two teams had these ratings before the game. So Real Madrid had a better ratings, 1600 than Barcelona. And so after the game, with this result, in order to update the elo ratings, we would just add this amount, which is kind of, you can think of it like how surprised compared to the model expectations. And so in this case, this would be for Real Madrid would be the previous rating right here, 1600, plus this K that we will have to estimate. We will see later, and this amount, which is a 1 here because the Real Madrid won, and minus the probability that Madrid would be expected to win. Okay, and so in order to compute this win probability, the expected win probability, we use this formula. Don't think about it too much. You have to look that it only depends really on this symbol, delta symbol right here, which is just the difference in elo points between the two teams that are involved in the game. And it's basically just a sigmoid function, which maps, say, an unbounded continuous variable, which like this, like difference in elo points, to a probability, to a value between 0 and 1. And so let's say that for a given game, there was a difference of 200 between the two teams. The expected probability, if let's say that S was 400, which is the blue line right here, would be around 0.75 probability, 75% probability of winning. And so we will have to tune this S parameter so that we get reasonable probabilities. So with this system right here that we've seen, you could implement this, but it is probably good to add some more context. And one of the things that every elo rating system that I've seen in this context is to take into account the home court advantage. As you see here, this is the average annual point difference of teams playing at home throughout the Euroleague's history. And you see that the overall average is around 4 points. So there is a clear home advantage. And so we might want to take that into account and include this in this calculation, in this difference in elo rating points that we saw before, by, let's say, adding this a given value that we have to estimate, like the previous parameters that we've seen before, and so we will add this value in this calculation, or we will subtract it if the team plays away. Another thing that I included is the margin of victory. So I took into account that wins by a wider margins, let's say, matter. So that not every win is the same, because wider wins might mean something. And so I include this parameter right here, this multiplier, this margin of victory multiplier, and the formula to calculate this, it's a bit tricky. Don't look at it too much. Just know that it depends on the elo rating difference right here that we've seen, and this D, which is basically what is just the difference in points in that game. Yes, and the last piece, I promise, is it's just one more thing to consider is the system in this case starts in 2000, which is the first season of Euroleague's history, and at that point every team starts with the same ELO rating, which I set to 1300. And so since we are running this system from this 2000 season to right now, we might want to consider not returning every team's rating to this baseline rating 1300. So it's usually the case that good teams from one season are good teams in the next season. And so I basically do a weighted average of the previous year's last rating and the mean and the overall mean, so that very, very good seasons or very bad seasons will tend to come back to the mean, to regress to the mean. And that's just the last part of the model. Now we just need to estimate the parameters that we saw. I just did a basic grid search where I set out a grid with the reasonable values and see what combination of these values predicted the best proportion of wins. And in this case, well, in order to score this model, I basically chose the winner of a game to be the team that had the highest ELO rating at the beginning of the game. And with this loss function, this were the values that I found best. So let's look at an example. Let's say the same game as before. And this way, so we had the previous ELO rating of Real Madrid. We had this K that we saw here in the previous slide that we set to 25, and the surprise factor that we saw before, and so from 1600, Real Madrid will after this game will be updated to 1610. Take note if the expected win probability would have been lower, this right here would be closer to 1, and then the amount of points added to Real Madrid's rating would be higher, meaning that the model expected Real Madrid not to win that much, and so it would be, if it wins, it will be more surprised, and I would update the ELO rating by a greater amount. And that is it. You made it. We have set the ELO rating system, and we can look at some results right now. These are basically every line here. This is every team in EuroLeague's history, how they have performed based on this ELO rating system, and I've highlighted the Spanish teams in my case, and yeah, and if you follow the Euroleague and you've been following it for the last years, they make sense. The results make sense, and yeah, it's pretty cool to see how every team has performed throughout the Euroleague's history. So by the time I finished this, having this system set up, the pandemic hit, and so the EuroLeague stopped, and they even got canceled. Some leagues did finish after a few months, but the EuroLeague just canceled the league, and so there was no winner or anything. So I said maybe it would be fun to use this ELO rating system to simulate, and predict who would have won the season. And so that's what I exactly went to do. And so now I already had these baseline ELO ratings, which were the last ones that I had. And so from this starting point, I went ahead and used this to create a predictive model of the point difference in a given game. And it's just a very simple linear regression model with just one covariate, this ELO ratings difference that we saw before. And that is it. From this, I predict a point difference and based who wins based on this. The full model is this. It's at the time I was learning getting into Bayesian statistics, and so it's a Bayesian model with some priors, but the basic idea is just some linear regression. I used Bayesian model just because it was fun, and I could assign some priors to the parameters, and I also directly got some samples of the parameters to simulate from. Here is how the model fits the data. So this is some posterior predictive checks and it does seem to do a good job of simulating this point difference. And so with this model, I just needed to predict the point spread in each game sequentially, and base the ELO rating, as we saw before, based in this predicted score point difference. I did this, so I do that for every game of the season, and I repeat that 10,000 times. So there is a lot of uncertainty in these results, in this who will win, and so I repeat the 10,000 times just to make sure that I explore every possible situation, and yeah. But on the way, I found a few challenges doing this. It was straightforward to do it for the regular season, because we have the games are all set, so we know what teams play what teams. But for the playoffs, we only the first 8 teams, the best 8 teams, classify, and so in each of these 10,000 simulations, different teams might go to the playoffs, and these playoffs consists of a series of the best of 5. the best of 5 games wins. And so that was a little tricky. And finally, for the final 4, I could have made some more adjustments, but I just assumed that all 4 teams that played away from home. This is not usually the case. Many times, a team that's in the final 4 will play at home, and so this might be something to improve the model on. And with this simulation, these are the results. I found out that Anadolus Efes Istanbul was the most likely winner of the Euroleague, and followed by Real Madrid. If you looked at the initial ratings, we saw that Real Madrid was actually first in the Elo rating, followed by Anadolu. But I guess if you look closer, the model, the Elo rating had picked up some trend, some really good trend in Anadolus Efes Istanbul that gave them a great edge. And so these probabilities are basically just the percentage of the proportion of times that Anadolus Efes end up winning out of all these 10,000 simulations. And we can calculate, the probabilities of anything really we want. We can calculate the probability that a given team, for a given team to make the final or the final 4, the playoffs. And yeah, so we can, the Euroleague never finished, so we can declare Anadolus Efes actually the winner of last season. One last note of what I would like to do in the future. So based on these simulations, one interesting thing that we could do is just update after every week. What are the probabilities of all the teams to make the playoffs or get to the final 4? This could be easily implemented with the code that I wrote before, and so that's one thing that I would like to do. And also, what I started out to do these in-game win probabilities with these baseline ratings, I can now use the play-by-play data to compute the win probability at each event of a given game. And I want to implement everything open source, and I might include this in this package. But I'm quite short on time, and I need your help. If you're into basketball analytics and you are an R user, I suggest you to give it a try. Try to do some analysis and give me some feedback. See what works, what doesn't work, what could be improved, and so that way I might find time to improve on this open source project. And that is it. I hope you found it interesting, and thanks.
Thank you for your presentation. It was quite interesting. We have a couple of questions now, but I want to reiterate, if you still have questions, please ask them in the YouTube chat, because you are still on time to have it answered in the stream. So the first one is Do the winning probabilities depend only on the team elo and home advantage? Could it take into account individual players?
Yes. Of course, you can make it as complicated as you want. This was, a side project, and but one interesting thing is that even like the more professional predictive models, and they're quite simple, and they do a quite good job. I've seen also that you could include, as you said, the I don't know, players metrics, or even player. You can take into account if a player is injured, or if a star player is injured. Another thing that I've seen used are related to this home court advantage is the distance that the away team had to travel to play the game, which might be a good predictor of this.
So it's a use case for anyone that wants to expand your work.
Yes.
So any volunteers can tackle this, please. Next question. Do you think that a model that also works with player elo system could outperform one with just teams elo? Which do you think are the most important steps to define a player elo model?
That's interesting. I think I haven't seen any elo rating system for individual players in basketball. But yeah, it makes sense, although I'm not sure how it will work. Because here we just take into account, we just update it after every game, for a win or for a loss. So yeah, but it probably could be implemented, but I'm not sure how.
Again, volunteers are welcome to try this. Next question. Do you think that this approach will work well in the NBA, which usually is more impacted by individual performance and team performance?
Yes, as I mentioned, this kind of rating is used in the States. 530. I actually got the idea from 538's model. They have pretty good documentation on their model, and yeah, they use it. It's pretty much the same. They have developed it a bit more, and it takes into account a lot more stuff. But it is doable. I mean, they have done it in a lot of sports. I think some official organizations, I think the soccer ranking is actually, I'm not sure, but I think it's based somewhat on this. So yeah, it's simple, but it seems to work.
Do you consider adding the match points difference in the formula?
Yes, we did include it. If you remember, maybe I can show you.
Can they show you again the slides, please?
And the last thing we added, right here, we did this parameter right here, which is calculated by this. This D is that point difference in a given game, the observed point difference, so that a win by a wider margin matters more than a win by closer.
So thank you for the answer. So the points were taken into account.
Yes.
You can remove the slides now. Thank you. Could the simulation start with different elo values for each team? What will be the impacts?
Yes, but why would that be? At the beginning, so I started the system, when we didn't really know anything about the teams, I guess. I mean, we could have, if you include, I don't know, players' stats, but, I wanted to keep it simple. And this is actually what they do in every model that I've seen. You're interested, obviously, for the first seasons, the system might not know yet what teams are best. They're still probably picking up. But after the first, second season, it's probably gonna pick up who is good and who's bad. And with this season to season carry on that we do, we don't go back to the baseline rating. We keep part of the rating from last season, so that helps.
I also think that all chess players start with the same elo, and then they either win elo or lose elo. So I think it's common practice. Thank you for the answer. Again, if you have any questions, please, it's the time to do it now. I only have 3 more here. Can a playoff game have more weight than a regular phase game?
Yes. Yeah, you could have. Yeah, that might be a good, interesting thing to add. Yeah, I'm sure. Yeah, that's a good idea actually. And yeah, I'll think about it if I implement for this season.
So the DSPT community is already helping.
Yeah,
we can thank them. What did you use to do the simulations? I assume R, probably.
Yes, I wrote everything in R, and you can actually. I have a GitHub repository. I think I didn't include it in the slides, but we can maybe include it later. And everything is on GitHub, and yeah, everything is in R. It's just a for loop. I wrote some functions to update the elo rating system, and so I had a data frame with every game and every result, and then predicted the point difference for every game sequentially, and updated the elo rating. And yes, I did this all in R.
A follow-up question: how long did it take to run the simulation?
Well, I ran this like a year ago, but it wasn't that much. I think it was like an hour in my personal laptop. Yeah, so it's they're really very basic models and very basic computation. So yeah, it's straightforward.
Thank you. And how did you choose the value of initial, the 1300?
Yes, I just looking at the what others were doing. I saw that this is the usual value that teams start. And another thing that I didn't mention is that I also set like an overall average of 1500, so that teams kind of regress towards this average, which we saw, when in the carry on from season to season, and yeah, that's, I guess, by convention.
Okay, thank you. These are the 2 last questions, unless someone has another one. What are your usual data science use cases in Alba Berlin?
Yes. Well, in Alba Berlin, I actually don't really work with basketball stats per se. I work with the sports science team. They have player tracking data, and so they want to analyze players' performances and the training load, to prevent injuries or see when players are better or worse physically. And so we have data on how many sprints, how many changes of directions, the speed, the accelerations, and that's what we're trying to do. It's hard. It's a lot of data, and you can look at a lot of stuff, and so we're trying to get some insights on how to use this data, which is still quite new. There's not many teams in Europe doing this, like having a data scientist working on this type of data, and yeah, it's very interesting.
Okay, it's a very interesting job, actually. And final question. Yes, for now, it's a final question. What are your predictions for Euroleague 2020-2021? I think you have to continue your work this year.
Yeah, I definitely should. But we'll see. I kind of think that Barcelona is going to win in my model and in reality. And this time
is that the model talking or the heart? Is the heart talking, right?
No, not really. I actually like Real Madrid better, but yeah, they're very strong. Barcelona is really strong, and but yeah, now it will be a good time to predict it, and because now we could check how the model performed, because the last season wasn't played. So yeah, it's a good idea.
So any volunteers that want to help with your code, now it's the time. Please join Sergio trying to update the model for this season. That was the last question. I want to thank you again for being here talking with us. And I want to remind everyone in the stream that after my final slides, you will be able to chat with Sergio directly using our Discord channel. I just want to show my final slides. Right. So again, we have the call for proposals. If you have done anything in the data science field or area, or anyone that has made an interesting project, please fill up this form and contact us. We'll evaluate your proposal and probably contact you for a future meetup. It's really important to us that you fill in this survey. We are trying to get better at remote events, and for the foreseeable future, this is the format that you are conditioned in right now. But we are trying to improve interactability between you and the speaker, and continue to break barriers and sharing knowledge. So please fill in the report, the survey, so you can have your feedback and know what and where we can invest our time and effort to make these events worthwhile for you. And finally, this is the link for the network event. I also think that will be available a couple of seconds after the stream, after we end the session. And thank you all for being here and listening to this remote event, and hope to see you all in a couple of seconds in our Discord chat.